absolute value functions. So yesterday we solved them, okay? And we brought back interval notation. What's the other one called? Inequality notation was with the greater than, less than signs. And then interval notation with like the parentheses and the brackets, okay? We're going to continue with the interval notation today. When we talk about range and increase, decrease intervals, we're going to continue to use that format. And we're going to look at their graphs today. So hopefully we matched. What did you match 1 with? The f of x function. You matched it with c? I agree. Yep. What did you match 2 with? B. What did you match 3 with? And then 4 leaves you with A. What was something special about the 2 and the 3 that possibly caught your eye? They're reflected. How did you know that? Because they were negative. They flipped upside down. What makes them different from each other, though? The 2 and the 3. +2 versus -2 on the end. Good. They both have a -2 on the inside, and notice they both move to the right. It follows the whole inside opposite rule with our transformations. Good. Okay, so now let's analyze these graphs a little bit more. So looking at my function f, which is going to match with our graph of c, right? This is our f of x function. What is the vertex here? -2 and -2. Good. Look at that equation, by the way. Remember inside opposite? Do we agree that this becomes -2? And this is already -2? Ooh, fancy. All right, what is our range for that graph? Range is my y values, right? All numbers greater than -2. Good. And as interval notation, we're going to say we start at -2 and we go forever. If you have y is greater than or equal to -2, that is the same thing. That's just inequality notation. In Algebra 2, we're going to focus more on the interval notation. Because eventually we're going to have endpoints. It really does make life easier with the interval notation. All right, line of symmetry. That's the line that cuts it in half. It's something about -2. X equals -2. Good. The line of x equals -2. So if I were to do a little dot right here, that's the line that cuts it in half. And it's symmetric on both sides. That's like a mirror being put in the middle. All right, how about G? What is our vertex for G? And that is referring to this graph right here. It is +2, +2. Yep. How about your range? It's what? I just didn't hear you.
Oh, I said it was 2 from infinity.
Almost. Good. -infinity up to 2 because it got reflected.
Oh.
So I remember interval is our lowest to our highest. So it's going to go as low as -infinity for your y's, but stop at a y value of 2. Good. And our line of symmetry for this one? X equals +2. Good. Okay. J of x, which definitely should have been this one. Sorry. J of x. So we're going to look at graph D now. Whoop. There we go. What was our vertex for that one? X is 2, y is -2. And our range this time? -infinity. -2. Good. Remember parentheses and then a bracket. Because it's an actual point on, it's an actual y value on the graph. That's why it gets the bracket. Line of symmetry? X equals +2. Good. Okay. Our last one I don't know why it's not letting me change. There we go. Our M, which we said was our A graph. What is our vertex here? -2, +2. My range? 2 to infinity and beyond. Thank you for laughing at my joke. I appreciate it. And line of symmetry? X equals -2. Good. So what relationship do you notice with the vertex and the ranges for all of these?
If it's negative infinity to a number, if it's not reflected, then it's...
So I don't care about flipped, reflects, none of that. Just the actual vertex point and the range. What connection can you make between just those two pieces? What do you think?
One of the numbers for the vertex point is always in the range.
Which one? The one that refers to the y, right? Because my range is talking about our y values. So all the numbers you used in your range was the y value of my vertex each time. Bless you. All right, how can we compare the vertex to our line of symmetry? It's the x values. They always matched up. Remember that, okay? Now, kind of what it says over here in this little vertex form of an absolute value function. An absolute value function written in the form g of x equals a times the absolute value of x minus h plus k, where a cannot be 0, is in vertex form, okay? And the vertex is hk. So we noticed that each time we pulled out from in our parentheses or in our bars inside opposite, that value for h flipped its sign, but the k on the end stayed the same. Any absolute value function can be written in vertex form, and its graph is always symmetric about the line x equals h, which we just recognized that relationship to. It was always equal to the x value of our vertex, which they use h for that special point. All right, ready to do some Algebra 2 stuff? Here we go. I know, it's fun. So first we're going to graph. F of x equals the absolute value of x minus 4 minus 1. Determine when the function is positive, negative, increasing, or decreasing. Then describe the end behavior of the function. Okay, so let's graph this first. I'll go green. Where is the vertex going to be for this graph? For -1. Do we agree? Inside opposite, and then the outside stays the same, right? So 4, -1, x is 4, y is -1. That is our vertex. All right, I'm going to use that for the middle point in my table down here. How come? Because it's on the line of symmetry. It's going to be the vertex. So from there, I should have the same pattern on both sides. Okay, so I'm going to go up to 5, 6 for my x's and down 3, 2. So let's plug some stuff in. I don't like the way this looks. Come on. I never got a battery, by the way, if you can't tell. There it goes. There we go. Let's try this again, please. There we go. Now, plug stuff in. What number do you want to plug in first? 2, 3, 5, or 6? 2 sounds great. All right, what is 2 minus 4?
-2.
What is the absolute value of -2? 2. And what is 2 minus 1? 1. What else should match that? The 6 should. Let's make sure. What is 6 minus 4? What's the absolute value of 2? What's 2 minus 1? Woohoo! That worked. Okay, makes sense. They're reflective points. Okay. You want to try 3 or try 5? 3? All right, what's 3 minus 4?
-1.
What's the absolute value of -1? What's 1 minus 1? Woohoo! Let's make sure 5 works. 5 minus 4, absolute value of 1. 1 minus 1. Good job. So we have 0 and then positive 1.
So we're just plugging the x into the equation.
Yep.
Is that what we learned last, about the graphs last?
Kind of, yeah.
Is that how we did it?
Nope. Your A is technically like the slope of the lines. So you see how there is no number in front of my absolute value bars? So your slope is still 1. So that's something to keep in mind to be able to graph faster in the future also. Okay. We have our graph. Now let's answer some questions. Where is the positive interval? Okay, well, when we're talking about positive interval, it's referring to the y values. So when are my y values a positive number? So we're looking for positive y values. Okay, so if you look at your graph, it's happening in 2 different sections, right? If this is our x-axis, there's a spot over here, and there's a spot over here. Do we agree?
Yeah.
There's 2 pieces in the positive y range, okay? So we're going to use interval notation. That first little bit starts at what x value? If it's going to go forever and ever and ever, forever and ever and ever. So we know this is 3, we know this is 5. This is starting at negative infinity, and the whole thing's going to end at positive infinity. Right, the x like a number line, right? Goes from negative infinity to positive infinity. Yes. See this first little chunk from negative infinity to 3? That's your first interval where your value, your graph is going to have positive y values. So we're going to say between negative infinity and 3 to equal infinity. That's better. And we have another section from 5 to infinity and beyond. I'm going to do it every time, so just get ready. Yes, we should. All right. Why are there no brackets?
Because if it was exactly the AB0, it was exactly 5 AB0, and that's not positive.
Right. It's not a positive. 0 is not positive. 0 is not negative. Does that make sense? Okay. This is also talking about like no, I won't say that. We'll keep it at that. 3 and 5 give you a y value of 0, which is not a positive number technically. So it's going to stay at an open parenthesis. Okay. Next, my negative interval. Okay, so where on this absolute value do we dip under the x-axis? So these are looking at negative y values. Okay, so where are we under? So here's my x-axis. We have a piece that dips, right? And what x values is that happening at? 3 and 5 again. So in between 3 and 5, we have negative y values, okay? Those will always match up because those are your x-intercepts, okay? That's going to show what's above or below. That's the crossover part. All right, my next one. It says increase or decrease, and it has a question mark, and I don't know why I typed it that way because that doesn't make sense. Where is it increasing and where is it decreasing? Because absolute values always have both. So I don't know why I worded it that way. I don't know what I was doing. But we should just increase / decrease. There shouldn't be a question mark. I think I was thinking about something else. Absolute values always have both. Okay, it's going to go down and then up, or it's going to go up and then down, always. This particular absolute value goes down, right? And then it goes up. And at what x value does that direction change? At the vertex of 4. Good. And again, this is a number line, right? So we're going from negative infinity to positive infinity. So where would you say that we are decreasing on this absolute value? Between what and what?
Negative.
Infinity and 4.
There you go. Good. Boop. Okay, so we said between negative infinity and 4. And then where would you say we're increasing? 4 to infinity and beyond. So absolute values will always have one of each. You will always have an increased part and have a decreased part. All right, in behavior, as your x approaches negative infinity, what is your function doing? F of x, which is fancy for my y values, are approaching positive infinity, right? As x approaches positive infinity, as we move to the right, where are my y's going? They're also going to infinity. Look at your ends. Would you say that they're both going up?
Yeah.
Yes. So you might have in Algebra 1 just been able to say up and up. But of course, we're Algebra 2. We don't say up. We say positive infinity. So what can we state that's going to be true for absolute value graphs and their end behaviors? They won't always go positive,
They go to infinity.
but they will both go
The same direction.
the same way. So they'll both go positive or they will both go negative. Okay, what's up?
What about when they rotate it 90 degrees?
Then it's not a function anymore. If it's going sideways, then it fails the vertical line test and it's not a function. So that won't happen. Yep. We don't do a lot of rotations in Algebra 2 because of that. Because if you rotate it certain ways, it becomes not a function anymore. Geometry rotates because they're doing shapes. They're not worried about functions. We good? Okay. We're going to level up. Whoop, whoop. We're going to level up because they're going to give me a characteristic about an absolute value graph, and then we have to graph it based off of what they tell me. So this absolute value has a range of negative infinity to 1 and a graph that is symmetric about the line x equals negative 2 and has a y-intercept of negative 5. Okay, so let's go through this. If it has a range of negative infinity to 1, what information did it just tell me? How does range connect to something else on our graph? The y of my vertex. So because of this, I know that my k equals 1, right? So my vertex is going to be something 1. We know that much.
And then the x for the vertex is negative 2.
Yeah, how'd you know that? Because my line of symmetry. Good. This gives you your h value, which is the x for my vertex. So negative 2, positive 1, we know is my vertex. All right, and it has a y-intercept of negative 5, okay? So I know it crosses this point, but that's not a v. What can we do? If I know one point on one side, can't you do its reflection point on the other side? And what are we reflecting over? The negative 2, right? So if we were 2 dots over here, we're going to go 2 spaces over here. There's my mirror image. Remember, the vertex sits on that mirror. So if I know one point on the other side, I can do its mirror image on the other side. And now I have a V. Like that. Let's do another one. Now it tells me that f is positive over the intervals negative infinity to 0 and from 4 to infinity. And then it's going to be negative over the interval 0 to 4. It has a minimum value of negative 4. Okay, So giving me my positive and negative intervals gives me what key feature of my graph? Was it? Not for the positive, negative stuff. That would be true for increase, decrease. These are x-intercepts. Yep. So we have an x-intercept of 0, and we have an x-intercept of 4. So 0, 4. We know we're crossing here. I also know it's going to open up because it's negative in between 0 and 4. So we know it's going to dip in between, but it's going to open up on either end. Okay. The minimum value is -4. What is that giving me? It's giving me a piece of my vertex, right? The y value of my vertex, or the k. So we know k is -4, but like where? Like this is all y is -4. How do I know where to put my point? Yeah, directly in the middle of 0 and 4. Good, but with my symmetry. So what is directly in between 0 and 4? 2. So 2 -4 becomes my vertex. Okay. Mathematically, you just did 0 plus 4, and you divided it by 2 to find your halfway point. But yes, this is our mirror image. So now here is our absolute value. Good job. You passed my test. Now it's time for you to do one. Yay. So you try. There's one for you on the back. There are 3 characteristics that I've given you. It is decreasing over the interval -infinity to -3. And it's increasing over the interval -3 to infinity. So Arlington, remember what you said last time. This is where you want to use that. Okay. The graph has a y-intercept of 1, and the range is -2 to infinity. So I want you to try this top one on the back. Check with me. Do our graphs match?
Oh, I did.
I'm on the right track.
Okay.
I just haven't finished.
That's okay.
I got the right number.
So the first thing it tells me is increasing and decreasing. Okay. So it's decreasing first from -infinity to -3. And then it's increasing afterwards. So it's decreasing and then it changes direction to increasing when it hits that x value of -3. So from that, I know that h equals -3. That's what that gives me. Okay, so I have a piece of my vertex. From there, the graph has a y-intercept of 1. Cool, I'm going to use that for a mirror image. Okay, I'm going to use a mirror image here, but I can't really do it yet. Okay, so at this point, I really have nothing on my graph. Okay, because I know I'm crossing this somewhere, but I'm not sure where. I know I have a y-intercept of 1, right? So I could do my reflective point. 1, 2, 3, 1, 2, 3. I know I have a mirror image on this side because this is that axis of symmetry. Ah, come on, don't you do this. There you go. That's our axis of symmetry right there. Then it says that the range of f is -2 to infinity. So that piece gave me our k value. So now I know my vertex is down here. Oh, don't do that. And then here we go. So if you ever have the x piece of your vertex, you also have the line of symmetry. So that's kind of a 2-for-1 special when you get that information. What's up?
Why is it not a bracket for the range?
The range, oh, technically it should be. Yep. I would agree with that correction. Boop. All right, we good? Ready for word problems? Your favorite? Of course you are. Right, Serena? We are so ready for these word problems. We're just so excited. No, you don't. All right, the function m of x equals the absolute value of x minus 178 represents the absolute deviation in centimeters of a man's height in x centimeters from the average height of men in Florida. The function w of x equals absolute value of x minus 163 represents the absolute deviation in centimeters of a woman's height, x in centimeters, from the average height of women in Florida. Okay. Here we go. Interpret and compare the vertices of the graphs in this context. So let's look at the m of x function. So when we have m of x equals the absolute value of x minus 178, what is the vertex going to be? Oops, that should be a bar. What's your h value? 178, yep. And then what's your k value? What's being added on the end? 0. Yeah. So this is our vertex. Because in your bars. Your h is in your bars. So let's go ahead and do the woman. X minus 163. What is that vertex? Comma 0. Good. What are these representing? What? Specifically what height? I heard it. Someone whispered it. Average. Yes, these are representing the average heights. Okay? With 0 deviation from it. That's what the 0 is showing. Now this is the average height of a male or man or woman in Florida. Okay, how would their vertices compare to each other? If I actually graphed these, Dion, what do you think? What would their graphs compare to be? Exactly. You have an idea? Kind of. Not this way, though. What do you think? Yeah, so yeah, they would be shifted down the x. Which one would be further down the x-axis? The 178, the male, right? So the m graph, I'm going to do m vertex. The m vertex is 15 to the right of the w vertex. Okay, so these are showing average heights. All right, now it wants me to compare the absolute deviations for a man and a woman who are both 170.5 centimeters tall. Okay, so we're going to plug that in for x for both of them and compare our answers to each other. So you and your partner, one of you do the m, one of you do the w. Plug in 170.5. Ready, set, go. All right, so who plugged in 170.5 for the man? Tamar? Is your hand raised? No? You sure? Did you do the man? The man function? Why? 7.5, yes, good. So when you subtracted it, you get negative 7.5 in your absolute value, but that's just 7.5, right? That's just showing that they're 7.5 centimeters under the average, right? That's what that negative means. All right, who did the woman? Maddie, what'd you get? 7.5, good. And it was a positive 7.5 this time, right? So that means that this woman is above average 7.5 centimeters. So if I compare, my results are what? The same. They're equal. Yes. Okay, so the heights of the man and the woman are both 7.5 centimeters from the average height. What's up?
For the woman one on the right, you put negative 168 instead of negative 163.
Oh, thank you. I did 8 instead of 3. Thank you. Okay, so the heights of the man and woman, whoever they are both 7.5 centimeters from the average height. A difference would be that a man of this height is under the average, a woman of this height is above the average. But we noticed yesterday with absolute deviation, it didn't matter above or below, it was just looking at the difference. They both have a difference of 7.5. Yeah? One more. All right, we're racing. You and your table partner, you're doing a swim race. Let's see. One of you, so the function is one of you and the graph is the other. Go ahead and figure out which one's which. Who wants to be the function? Who wants to be the graph? Okay, so now we're going to see which one of you won the race. Okay, so who swam, what is it, the 25 yards? Who swam the 25 yards the fastest, going from that point and coming back? Ready? First one is the easy one, the graph. How long did it take the graph to finish this race? 25 seconds. How'd you figure that out? Yeah. It starts and stops. Those are my seconds, right? So whoever my graph person is, it took this 25 seconds to finish the race. Okay? Now, my function friends, how do I find your x-intercepts? Because that's what I need. How am I going to figure that out? Make y equal to 0. Good. So we need our x-intercepts. So that is when y equals 0. I don't see y though. I see d of x equals negative 1.5 times the absolute value of x minus 50 over 3 plus 25. There you go. D of x is my y. So make our whole function equal to 0. So I'm going to do negative 1.5 x minus, do you want to go ahead and change 50 over 3 to a decimal? Yeah? Double check me. I have 16.6. Yeah? Okay. Oh, 6 repeating. Do you want to do 16.7? Okay. Sounds good. And then plus 25 equals 0. All right. We're going into yesterday. What should I do first? What should we do first? Subtract 25. Move that to the other side. Equals negative 25. All right, now what? I can't move that yet. It's in my absolute value bars. There's something else still in my way. Yes. Divide by negative 1.5. So I have the absolute value of x minus 16.7 is equal to what? What is negative 25 divided by negative 1.5? It's a positive something. Oh, interesting. So I'm going to call that 16.7. How lovely. So now we can make our two equations, right? We're at the point where we can solve for x. So what's inside of my absolute value, the meat of our absolute value sandwich going on here? X minus 16.7 is allowed to equal 16.7, and x minus 16.7 can equal negative 16.7. Because positive or negative of the same thing inside the bars will still result in the positive 16.7 on the outside. All right, so both of these we're adding, right? Adding. Here we go. Okay, so this one is, you said 33.4. And what's the other one?
16.7 times 2 is 33.4.
So what did that just give us?
A time.
It gave us our beginning and end, right? We start at 0, that makes sense. And then how long did it take my function people to swim? 33.4 seconds. So who's faster? The graph people. Yay! Our graph people win. Okay. So the graph friend is faster by how much? How much faster was the graph person than our function person? 3.4 seconds. Nope, not 3. 8.4, yep. It's faster by 8.4 seconds. And how do we find that out? Yeah. 33.4 minus 25. That's how I find the difference. So my graph friends, congratulations. You are the winner.
What do we get?
Gold star. You're welcome. Yeah? 1 second. Questions for me about 1.5? Okay, so I know it's graphs again, but hopefully they're not as scary as the ones we've already been doing. Okay, hopefully they're a little bit better. Hold on. What we're doing the rest of today is you're working on your Chromebooks. You're working on 1.4 and 1.5. Okay, some of you already started 1.4 on Big Ideas. So good job. Keep working on that. If you haven't started, you got 2 assignments. Okay.